Now there are various techniques that we are having. Now bubbles, we all know that in the worst case, bubble selection insertion. Now let me divide the cases. The worst case, average case, and the best case. So supposedly I'm talking right now about the worst case. Worst case में bubble sort also takes of the order n square. Selection sort also takes of the order n square. Insertion sort, even quick sort is going to take of the order n square time, whereas merge and heap sort will take of the order n log n time. These are the worst case complexities that we have calculated for all the sorting techniques while doing them. Now, in the average case, all the other sorting techniques will perform almost like the worst case, except for a quick sort. जिसका worst case क्या होता है? Yesterday only we saw, if we are having almost sorted technique, then it is almost a worst case for quick sort. अगर हमारे पास already sorted list है, तो the average case complexity for quick sort is of the order n log n, which is less than the n square. We will just revise how, and rest all remain same as the worst case. Average case may be, बाकी सबकी average case complexity is same as the worst case complexity, n log n and n log n. Now in the best case, as we have seen, bubble sort की complexity can be improved to be of the order n when we can compare and we stop the algorithm from exchanging by taking a flag as suggested that day. If we take a flag bit and we check if there is an already sorted algorithm, we need not do the swapping again and again and again. So the complexity of bubble sort can be improved to the order n, while the complexity of selection sort even in the best case still remains of the order n square. So the selection sort के case में complexity still remains of the order n square, because every time it is going to calculate the smallest and select the smallest and then put it in the right position. So the best case complexity is also of the order n square. While in insertion sort, since we are inserting the element as and when it is coming, we have seen that in the best case insertion sort sorts the list linearly. So the complexity again is of the order n. Rest all, again, even in the best case, the complexity remains of the order n log n. So this is a basic analysis regarding the time complexity of the techniques. Now, if I'm talking about the space complexity, so in the worst case, I'm talking about the worst case space complexity. Whatever my list size is, excuse me, that much space I'm going to take. So the extra space that I'm going to take for the algorithm, list तो already created है, तो हमने extra space तो कुछ लिया ही नहीं है. Already created list में ही हमने exchanges करे हैं with a few constant temporary variables that might be taken. So the extra space complexity required for the bubble sort is of the order 1. Extra space जो list बनी हुई है वो तो already of the order n size ले ही रही है. उसके अलावा we are not taking any other n size data. Same for selection insertion. Extra space complexities of the order 1 only. While for a quick sort algorithm, since I'm going to partition and I'm going to store the intermediate results, then I'm going to turn them back. When I'm partitioning and I'm calling again and again and again, there has to be a space where you are saving the stack when the calls are going to happen. So these space complexities of the order n here. Similarly, for merge sort, since recursive calls are going on, the space complexity rises to be of the order n. While for heap sort, again same heap को आप call कर रहे हो, extra space is not required here also. Quick sort or merge sort के case में you are breaking the problem into two halves, और not if two, so how many halves, whatever. So two halves that may be of equal size or not. Then further breaking, further breaking, further breaking. So you have to save from where you are breaking the halves. To save that, you require of the order an extra space complexity. While again for heap sort, you do not require anything extra. Same array में सब कुछ चल रहा है. So the extra space required is nothing. So irrespective of whatever is the size of my input data, bubble selection, insertion, and heap sort are not going to take any extra space. While quick and merge sort will require of the order n space on your systems to be able to perform correctly, right? And the best and worst case complexity. So here you can all understand that possible best case complexities are for bubble and insertion sort in the best case, which are linear. Merge and heap sort are going to give you n log n complexities. Quick sort gives you n log n for the best and average case, whereas in the worst case it is also of the order n square only. Bubble, selection, insertion are going to give you of the order n square, although insertion does perform better than the other two techniques as the number of comparison reduces. Even in the worst case, the number of comparisons would reduce as compared to the bubble and the selection sorting technique. So this is about the time and space complexity. Now, if I am talking about whether the algorithm is in place or not, that means algorithm should not use any extra space for manipulating the input, but it may require small non-constant extra space. So, and we have to check whether the sorting algorithm is stable or not. Though new terms I am introducing right now. Stability of an algorithm. Now the other terms on which I can compare the algorithms, the other two terms are whether they are in place, the sorting is happening in place or not, and whether the algorithm is stable or not. Now, what do I mean by in place and stable? So I am again saying when sorting technique does not use extra space नहीं चाहिए हमें exchanging के time पे, except for some constant variable. When I do not require any extra space, in that case it is known as in place sort. जहाँ पे है वहीं पे sorting हो रही है. So the sorting is happening in place. As you all know, as we have just seen, the only where in place sorting is not required is the merge sort, क्योंकि हम एक temporary array लेते हैं उसमें copy करके then we copy it back. So in place sorting does not take place in the merge sort. बाकी सारे arrays में same array में we are going to replace or exchange or do whatever. So all other techniques are using in place sorting. Only merge sort में we were taking a C array extra जिसमें हम merge करके then we were copying it back. So merge sort is not an in-place sorting technique. All others are the in-place sorting techniques. What do I mean by stable sorting technique? Stable sorting technique का मतलब है, supposedly I am having a list where I am having some elements which are repeated. So जब when I am creating the final list, if the element which was coming first in the list is still coming the first, it has not been swapped, then it is called a stable sorting algorithm. That means this is although sorted, supposedly it was like 1 and 1 are still coming here. So when I will be finally having the sorted list, that should be 1 1 1 and 2. So this one should be the one that occurred first in the original list. This should be the second. If the occurrence of similar elements is in the same order as in the original list, then it is called as a stable sorting algorithm. Otherwise, it is not called as a stable sorting algorithm. I will again repeat. If the order of elements which are same remains intact in the original and the sorted algorithm, then it is a stable sorted algorithm, otherwise not. If this one is coming after and this one is coming first in my algorithm, then it is not called a stable sorting algorithm. So bubble sort is stable sorting, selection sort is not stable sorting because it might be having the changed position. Insertion sort is once again a stable sorting algorithm, whereas quick sorting is not stable. It will change the position of the similar elements. So it is not a stable sorting algorithm. Merge sort is a stable sorting, whatever is coming first will remain first, while heap sort is essentially not a stable sorting algorithm. So only bubble, insertion and merge sort, they are stable, while selection, quick and heap sort are unstable sorting algorithms. And if you all remember, I have already told you about the online algorithms. Insertion sort happens to be the online algorithm also. What I mean by online is जैसे जैसे array में new list में new data is coming, we can sort that. As the data is coming, we can keep on sorting it. Rest all the algorithms are offline algorithms because they require the entire list, then they will sort. Insertion sort mein, it does not require the entire list to be sorted. It is picking up an element, it is inserting in the correct location. So as the data is coming, it can keep on sorting. So it is the only online sorting out of all the algorithms available. So this is an analysis of various sorting techniques. Depending on where, in which application we are using, we will be using a particular algorithm. So just for example, now if stability is important or if space is important, then you have to see which sorting is to be used. If stability is not important, if only quickness is required, then you have to see which sorting technique is to be used. Now agar mujhe merge sort hi karna hai, so we should use a linked list or not. Such questions you can ask, and then you can see how are we going to compare all these techniques. These are the parameters. So depending on the application, kaun se parameters aapke application pe applicable hai, you can use a particular sorting technique.